Hello to everyone. In our previous videos, we have discussed the concept of rank of the matrices, how we can find out the rank of the matrix by using the normal form, by using the row echelon form, by using the column echelon form, and after that, we are using that concept into the solution of equations, right? Solution of equations of m n variables, solution of equations of n variables, right? तो m equations के साथ we are using n variables, right? So before that we have done the concept of solution of equations by using matrix method and matrix inversion method. We have choose these two methods in the solution of equations, and now we are going towards the another method, that is solution of equations by using rank of the matrix. How we can find out the solutions like this? Suppose we have m equations with n variables. So first of all, we should write the system into this form, right? Ax is equals to b, which we have already discussed in the solution of equations. Here, A is the matrix of order m is to n, and X is the matrix of unknowns, and B is the matrix of constants, right? So here the order of the matrix A is m is to n, where m are the number of rows and n are the number of columns. And this X contains n variables, right? This X contains n variables which we want to calculate from the system of equations, right? To solve this system of equation, first of all, we should write the system into the form of A, B, right? A colon B. A colon B means this is called augmented matrix. Augmented matrix. What is the role of this matrix in this solution? First of all, we define the given matrix into the triangular form. What will you do? In the second step, we have to convert this matrix into the triangular form. Basically, not the triangle form, it is the upper triangular form, right? The upper triangular form, whenever you convert this into the upper triangular form, then we have to check what is the rank of A and what is the rank of AB. Means, what is the rank of this augmented matrix and what is the rank of A. And if rank of A is not equals to rank of AB, whenever you solve this augmented matrix and convert it into the form of triangular matrix, then we see that what is the rank of A and what is the rank of A colon B. If these two ranks are not equal, so it means the system has no solution. System has no solution. In second case, if rank of A is equals to rank of AB, if rank of A is equals to rank of AB, there is some doubt. First of all, you should compare rank of A is equals to rank of AB is equals to n. What is n? N is are the number of variables, right? N is the number of variable. So first of all, you check rank of A, then rank of AB, and last one is number of variables. If these three are equal, then solution is consistent. Solution is consistent and unique solution is there, right? Solution is unique means आपको पता है what is a unique solution, तो solution is unique. But in second case, if rank of A is equals to rank of AB and it is less than n means number of variables जो है उनसे इनकी वैल्यू कम होगी. So rank of A is equals to rank of AB but it is less than n, then solution is consistent but infinite number of solutions are there. infinite number of solutions are there. So basically, this is our structure to solve the system of equations with the help of rank of the matrix, right? So first of all, we are taking an example how we can find out the solution of m equations with n variables with the help of rank of the matrices, right? Suppose we have this system of equations in which we have three equations with three variables, right? Three equations with three variables. So first of all, we should write the system into the form of 1, 2, minus 1, 3, minus 1, 2, and 2, minus 2, 3. Here, we should write x, y, z, which are the unknowns, and is equals to 3, 1, and 2. And we are converting the system into the form ax is equals to b, which we have already told. And after writing this system into ax is equals to b format, we have to write the augmented matrix. How we can write the augmented matrix? First of all, you should write the elements of A, then separation may be taken as a line or in terms of column, right? And 3, 1, 2 here. First of all, we should convert this format into 000 form. Means we have to convert this A matrix into upper triangular format, right? So upper triangular format के लिए what will you do? First of all, you should make these two elements 0 with the help of this one. One is the leading entry for us. So first of all, you should convert these two elements 0. So we have to use R2 changes into R2 minus thrice of R1, and R3 changes into R3 minus twice of R1. So whenever you change this to 1, 2, minus 1, 3, and here multiplying this with 3, subtracting from this 0, multiplying this with 3, subtracting from this minus 7, multiplying with 3, subtracting from this 5, multiplying with 3, 9, subtracting from it is minus 8, multiplying by 2, subtracting from this 0, multiplying with 2, subtracting from this is minus 6, multiplying with 2, subtracting from this is 5, multiplying with 2, 6, subtracting from this is minus 4. Now, what will you do? You have to make this element is equals to 1. How we can make it 1? First of all, you can take the operation like I am taking R2 changes into R2 minus R3. You can take this operation. Whenever you take this operation, we can convert this into what will you get? That is 0, minus 7, 5, and sorry, we have to convert R2. So R3 should be same, right? And this minus this becomes 0, this minus this becomes minus 1, this minus this becomes 0, this minus this becomes minus 4, right? Now make this entry is equal to 1. So multiplying it with R2 changes into minus R2. So R2 changes into minus R2 implies that 1, 2, minus 1, 3, 0, 1, 0, 4, 0, minus 6, 5, and minus 4. Now make it 0 with the help of this one, right? Make it 0 with the help of this one. So what will happen? Now write this is equals to same. First row is same. Second row is also same. And this is whenever you take the operation, R3 changes into R3 minus plus 6 times of R2, we get 0, 0 at this place, multiplying this with 6, adding to this 5, and multiplying this with 6 and adding into minus 4, that is 20. So we are here with these entries 0, right? So now it is which form? That is triangular form. After converting it into the triangular form, first of all, you should see this one. This is our A matrix, right? This is our A matrix. So what is the rank of A? Find the number of non-zero rows. Number of non-zero rows are 3 here. So it means rank of A is 3. And you should check rank of AB also. Means number of rows in this complete AB matrix, right? So AB matrix में how many rows are there which are non-zero? There are 3 rows again. And n are the number of variables, that is also 3. So which criteria fulfilled by this augmented matrix? That is rank of A is equals to rank of AB, which is equal to the number of variables. It means the solution is consistent and has the unique solution. Means ये जो criteria हमने दे रखा है, ये criteria satisfy होता है. जब ये criteria satisfy होता है, what does it mean? Its mean is rank of A is equals to rank of AB is equal to the number of variable, means system has unique solution, right? So system has unique solution. After getting the unique solution, what will you do? Again separate A matrix, right? A matrix first. Write X, Y, Z, which are the unknowns, is equals to B. Means after completing all these steps, again separate it into this form. AX is equals to B. Whenever you separate it into this form, then the system becomes this A matrix with XYZ unknowns, and here we have the constants. Solve this system like X plus 2Y minus Z is equals to 3 and Y is equals to 4 and 5Z is equals to 20. Here there is no need to solve y is equals to 4. It is obvious y is equals to 4, and solving it we are getting that is also 4, and substituting the value of y and z into first equation, and we are getting x plus 2y minus 4 is equals to 3, x plus 8 minus 4 is equals to 3, and value of x becomes minus 1. Right? The value of x becomes minus 1. So there is the solution. X is equals to minus 1, y is equals to 4, and z is equals to 4. We can check whether the solution is true or not. You have to put the value of x minus 1 here, y is 4, and z is 4. You can check the given solution which you have already calculated. This solution satisfy the given system of equations or not. If it satisfies the given system of equation, it means definitely it is true. We are getting the right solution. But if the value of xyz does not satisfy the given system, it means solution is wrong, right? So first of all, what will you do? First of all, separate the matrix into the form Ax is equals to B. Then write the augmented format. What is the augmented format? You have to write the matrix A here and the matrix of constants separated by the line or the column. Then convert the given matrix into the upper triangular form by using the operations which we have already told in our previous videos. Please check those videos and go for this topic also. Then we can find out the rank of A. First of all, check this matrix. What is the rank of A? Then check the whole matrix. What is the rank of AB? And N are the number of variables. So here number of variables are 3. Now these 3 are equal. If these 3 are equal means it is a first case when the system has the unique solution. So if system has unique solution, then we can separate this system again. आप इसको फिर से separate कर दीजिए. तो A into this is unknowns and these are the constants, right? Then solving it again by multiplying these two and getting these 3 equations and find the solution for y and z. Whenever you calculate y and z, substitute this y and z into this equation and find the value of x also. And this is our final solution, which is a unique solution of the system of equations, right? So अब second format क्या है? What is the second form of the question in which we can get the infinite number of solutions, right? In which we have the 3 equations and 4 variables. Here I have given an example in which we have discussed the 3 variables and 3 equations, right? So which we can solve by the matrix method also, matrix inversion method also. And now we are pursuing one more example in which we have 4 variables, right? But 3 equations, 4 variables and 3 equations. So how we can solve that system with the help of rank of the matrix? Just we have to see this, our second example. In this question, here we have 3 equations, right? 3 equations with 4 variables x, y, z, w. First of all, write into the simple format 1, 2, 3, minus 1, 2, 3, and -1 with -2, and 4, 5, 3, 0. This is A matrix. XYZ matrix of unknowns with W, right? XYZ W, and which is equals to 5 to 7. So what we are getting here, first is it is a matrix of order 3 is to 4, and this contains 4 variables, so it is of order this is 4 is to 1, right? And here we have this matrix which has the order 3 is to 1, right? So in this, we are expressing the given equations into Ax is equals to B. Now write the augmented matrix here. So what is the augmented matrix here? A separated by B is equals to 1, 1, 2, 1, 5 for constants, 2, 3, -1, -2, that is 2 constant, 4, 5, 3, 0, and here 7 is constant. Means we have to write this A matrix as a whole and then separate by 5 to 7. Now, after making the augmented matrix, what will you do? You have to do these two elements 0 again. We have to convert the given system into the upper triangular matrix again, right? So first of all, you should make these two elements 0. So R2 changes into R2 minus twice of R1, and R3 changes into R3 minus 4 times of R1. So we are here with 1, 1, 2, 1, 5. First row as it is. In the second row, whenever you multiplying this by 2, subtracting from this 2, we are getting 0. Multiplying this by 2, subtracting from this 1. Multiplying this by 2, subtracting from -1, that is -5. Multiplying with 2, subtracting from this is -4. Multiplying this with 2 and subtracting from this, that is -8. Now, multiplying this with 4, subtracting from this 0. Multiplying this with 4, subtracting from 5, that is 1. 4, subtracting from this is -5. 4, subtracting from this is -4. 4 से multiply 20 and subtracting from this is -30. In this way, we can make these two elements is equals to 0. After converting into 0, now we should make it 0 with the help of this one. So with the help of this one, whenever you make it 0, so it becomes R operation will be R3 changes into R3 minus R2. Then our final matrix will be 1, 1, 2, 1, 5. First row as it is. In the second row, that is also as it is, -5, -4, -8. And here we are getting 0, 0, 0, 0. And that is R3 means -13 minus this one, that is -5. Right? So after converting into this format, that is a upper triangular format, we had to check what is the rank of this A. Right? So what is the rank of A? In the A, we have to observe there are two non-zero rows. First row, second row, in this, all the elements are 0. So rank of A will be 2. And rank of AB, what is a rank of AB? Rank of AB, you should see the complete matrix. Right? So in this complete matrix, how many rows are there which are non-zero? Yani ki 3 rows are there. So rank of AB will be 3. After that, number of variables are also 3. But rank of A is not equals to rank of AB. Okay. If rank of A is not equals to rank of AB, so what will be our result? Our result is final. That is, system is inconsistent. System is inconsistent and has no solution. सिस्टम का कोई भी सॉल्यूशन एग्जिस्ट नहीं करेगा. सॉल्यूशन इज इनकंसिस्टेंट एंड हैज नो सॉल्यूशन. राइट? दिस इज आवर सेकंड एग्जांपल. In this we have 4 variables and 3 equations, right? So we can find out the solution of those kind of equations also, which has 4 variables but 3 equations, by following these steps with the help of rank of the matrices. And now we are giving one more example in which we can understand about the concept of infinitely many solutions by rank of the matrix, right? Now we are taking this third example. In this third example, we have again augmented matrix AB, which is written in the form of 1, 2, -1, -5, and 4, 1, 3, -2, -7 with 5, 2, -1, 3, 0 with 3. Right? Here again, we have three equations but four variables, right? Three equations with four variables. So in this system, again, we have to make these two entries are 0. So R2 changes into R2 minus R1 and R3 changes into R3 minus twice of R1. So whenever you operate these two operations on the given matrix, first row as it is, second is this minus this, that becomes 0. 3 minus 2 is 1. This minus this is -1. This minus this is -2. And this minus this becomes 1. Similarly, R3 changes into R3 minus twice of R1, means you have to multiplying this with 2 and subtracting from R3, we get 0. 2 se multiply subtracting from this -5. 2 se multiply subtracting from this is, that is 5. 2 se multiply, that is 10, positive 10. And that is 2 se multiply and subtracting from 3, that is -5. Now, this entry is again 1. With the help of this one, make this entry is equals to 0. Means we have to use R3 changes into R3 minus 5 times of R2. Not minus, it is plus, because -5 is there. So whenever we add 5 into -5, that becomes 0. With the help of this, we can make it 0. So we are taking this one. 1, 2, -1, -5, 4 as it is. And second row is also as it is, because we are not taking any operations which are applying on R2. Here we are just applying the operations on R3. So whenever you multiplying, this is 5, 10, and adding into this, we have 5. That will be 0, sorry. Multiplying this with 5, adding into this. Multiplying this with 5, adding into this. Multiplying this with 5, adding into this. And multiplying this with 5, adding into this. Oh, what we are observing here, what is the rank of this A matrix? First of all, we should check what is the rank of this matrix. You can see this one. Here, A is the matrix, right? So what is the rank of A here? Here, two rows are there which are non-zero and third is 0. So rank of A. What is the rank of A? Rank of A is 2. There is no issue. And whenever you check this whole matrix AB, augmented matrix, then two rows are there which are non-zero again. So if these two rows are non-zero again, the rank of AB is also equals to 2. And how many variables are there? 4. Please check how many variables are there. X, Y, Z, and W. 4 variables are there, right? So 4 variables are there, so N is 4. So what we are getting, rank of A is equals to rank of AB, but this is less than N. Means that is our third criteria. In the third criteria, we have system is consistent due to this condition. System is consistent and has infinite number of solutions. System has infinite number of solutions. और अगर infinite आ जाए तो what will you do? For that, we have to write the system again into that form. Ax is equals to b. So 1, 2, -1, -5, and multiplying with x, y, z, w is equals to 4, 1, 0. And here we have 1, -1, -2, okay, and third row is 0, 0, 0, 0. Whenever you multiplying this with this, we have x plus 2y minus z minus 5w is equals to 4. And second equation is y minus z minus 2w is equals to 1. And third is not there. And whenever you multiplying this with this, we have 0. This multiplying with this, we have 0. It means third condition is not there. So what will you do in this case? Here, how many variables are there? 4, right? The number of variables minus rank of A, we will get 2. If we subtract rank of A from number of variables, that is 4 minus 2, that becomes 2. What does it mean? It means we have to take two variables which are non-zero and uh, they are variable basically. They are arbitrary constants. So we have to take z is equals to k1 and w is equals to k2, which are the two variables which are in the form of arbitrary constants. Matlab we can change their values, right? So k1 and k2 are the two specific variables, and now we are getting x plus 2y is equals to minus k1 plus 5k2 is equals to 4, and from here we have y is equals to 1 plus z. Z means k2, sorry k1, and w means 2k2. That is the value of y. Whenever you replace the value of y and z here, z and w here, k1 and k2, then we obtain the value of y variable in terms of k1 and k2, right? So whenever you replace this y into this equation, then we can find the value of x also. What will be x? That is 4 plus k1 plus 5k2, and this minus of twice of, I am taking here, minus of twice of 1 plus k plus 2k2, k1 plus 2k2, and you have to solve this. We are getting the value of x. So in this way we can find the value of x, y and z, but these are the variables value. As you have to convert the value of k1 k2, you have to change the values of k1 and k2 again and again. Suppose you are taking the value of k1 is 1 and k2 is 2, we are getting the different values of x, y, z and w. If you are taking k1 is 0, k2 is also 0, then we will get the another value. So there are infinitely many solutions which are dependent on the two variables. These are z and w, where z and w are the variable constants, or you can say these are the arbitrary constants, right? So in this way we can find out the solution infinitely many solution in some of the equations which contains more variables but less number of equations. So this can be possible with the help of rank of the matrix only. So we should do the practice for these kind of questions also. Before that, we have already done the solution of equations by using matrix method also, but in that case we had to use the three variables with three number of equations, two variables with two number of equations, but in this case we have more number of variables but less number of equations are there. So in this way we can find the solution of equations, right? So now we are completing our lecture on the basis of this, and we will come in the next video again. Meet you soon.